Hi, Piper. We met a long time ago. Gosh, it's been like 4 years in DC, when Sandra and a bunch of other people were there. I'm Ozzy's mom, if that helps you remember. Anyway, your mom and I were talking, and I thought I would do a little bit of the math for you on some of this, what looks like review. It's not something I can do like daily, but if this is something you need in the future, tell your parents or tell your mom, and I don't mind sitting down and doing this. So I'm gonna shut up and get to work. But what it seems like you're doing here, it must be kind of a pre-algebra type course or an algebra 1 type course, because what I'm seeing is you have some stuff with slope and rate of change, you have some stuff with slope-intercept form of equations, and I added some videos to the playlist that I set up, which is, it is set to like private, so you're the only one with the link, so if you want to share that link with anybody, they'll be able to see the playlist. I'm going to go ahead and start writing out some of the math on this as well, and you can always ask questions, you can put them in comments on there, and we can go from there. All right, so anytime we're solving an equation, what we're doing with solving an equation is we're working backwards, we're backtracking. And I like to just kind of think about it as, well, what you're doing is you're undoing what happened to x. And of course, nice simple equations, it's the same process over and over again. Like in this situation, I might add 5, giving me 23 equals 3 times x or 3x. And then I might divide, because that's undoing what was done to x. But what gets complicated is when this doesn't come out to a whole number, when we end up with something like that. And we're not used to seeing that, and that's one reason why sometimes we can get confused is, they show you one thing in class, and then they send you home, and it's like 10 times harder what they show you. Or it's 10 times different, whatever the case may be. Okay, let me send all my writing to the back here. Send backwards, and we'll upsize our image here. All right, so it looks like we're solving an equation. It's kind of obnoxious here. It's got all these ugly little decimals, and I tend to get rid of decimals. They've made this particular problem a little bit more difficult than I would like. But anyway, excuse me, I see here that we've probably distributed, which is where we probably got the 19.2 from, and minus 9.6. All right, so this looks pretty good here. Okay, let me actually just look at it without walking you through it. Hold on. Alrighty, so let's just kind of start from the beginning here. So, alright, so we start with the distributive property. We see here 3.2 times 6m, and then the minus 3. And I saw that looked exactly right, I think. Let's see, 3.2 times 6, 3 6s, that's 18. 3.2 times 6 is 1.2, 18 and 1, okay, so 19.2, and that's m, minus 3.2 times 3 is definitely 9.6, plus 2m minus 5.6 equals 12 plus 7.6m. Now, one strategy at this point is to multiply everything by 10. Multiplying everything by 10 makes the decimals go away, which sometimes just makes a little bit of a difference in how we're seeing things. So that is an option. I'm not going to do that. I'm going to go ahead and combine like terms, though. And that's something I saw you do underneath here. But what I want you to remember is you don't have to write them separately like that. What I would do instead, and let me get like a highlighter tool, is I want you to think about considering these two numbers as just plain old regular numbers. Don't even think about them as coefficients for a minute. So they're not even 19.2m and 2m, just 19.2 and plus 2. Well, they're both positive, 19 and 2, that's 21, so 21.2m. And then I want you to think about the other, I'll use a different color, as just integers, negative 9.6 and negative 5.6. Well, negative 9.6 and negative 5.6 would add together. A negative and a negative adds to be a negative. So negative 9.6. Oh no, it changed color on me. Let's try that again. There we go. Negative 9.6 and negative 5.6 is just like adding those two integers together. So 6 and 6, that's 12. 9 and 1 and 5, 15. So it's negative or minus 15.2. Think about this as minus or minus 9.6 minus 5.6 more. So we combine those like terms. Now that we've combined all the like terms, now I can do that whole thing where I add or subtract the variable to both sides and then the number on both sides. Well, what I do is I look, what do I have that's smaller? Is 21.2 smaller or is 7.6 smaller? 7.6 is smaller. I'm going to get rid of that. So I'm going to do whatever the opposite sign of what I'm looking at is right there. All right. All right, so now I have to subtract. So I have 21.2 minus 7.6, and that comes out to 13.6. And I will confession, in the interest of full disclosure here, I will confess to you that I do indeed use a calculator when I'm doing video. Because it's really hard to multitask, so to talk and do all of this stuff at the same time, it's really hard to do. And so because it is so hard to do, instead of trying to multitask and do the math and all the writing and talking and everything all at the same time, I use it at least one little crutch. And yes, I do consider a calculator to be a bit of a crutch. Okay. All right, we're all the way down to here, so we're going to add the 15.2 to both sides. Add the 15.2 to both sides. So 13.6 m equals 27.2. Now, one of the things that I want you to do for me when you're sitting down and going over this is I want you, at any point where you're like, wait, I don't understand what she just did, I want you to comment. You can put down a time, maybe, but I'm seeing where we're at in the school year, and I'm seeing where you're at in your curriculum, and if what I'm doing makes sense and you just needed someone to jumpstart you, awesome. If what I'm doing is, if I'm losing you, I want you to tell your mom. And I will go back and I will start fresher. And that is no big deal. Okay, did you see that answer there? Oh, no. No, nobody can see what you just did. Okay. There it is. M equals 2. Now, at the end of this ridiculous ordeal that is this equation, we should be checking our solution. Now, I'm not going to do that right this second, but I will tell you that I did check the solution on a calculator a minute ago, and it is correct. So I know that's the right answer. But man, that was a bear of a question. So the steps are the same no matter what the question looks like. Let's do a couple of these easier ones, or actually a couple of these with fractions, and let's look at some ways we can make our life easier, especially with fractions. I just moved my writing, not what I meant to do. All right, hold on, I got to lock everything together. Okay, now I should be able to move stuff. There we go. Okay, let's look at this number 9 right here with these fractions in here. Whoa, sorry. Hope we don't get motion sickness. Okay, so I see fractions. I want the fractions to go away. Now, one of the great things about equations is I get to add and subtract the same thing for both sides. Like here I have minus 7.6 m on both sides of that one that you can barely see the bottom of on that problem. You know, or I can add, like I can add 5/10 to each side if I want to, but I'm super lazy. So I see these fractions and I'm like, there's no way. I'm not dealing with those fractions. Let's make all the fractions go away. Well, if I can add and subtract the same thing to both sides, I can divide both sides by the same number. I can multiply everything by the same number. And ooh, that's useful. How about we multiply everything in this equation by 10? 10 times a is 10a. 10 times 5/10. Well, the great thing about multiplying when it's a fraction is if the numerator, and in this case, remember, this is 10 over 1, right? So the 10 is a numerator. The numerator and the denominator are the same. They cancel out. That means they just disappear for that particular product, so multiplying two things, right? So the 10s are going to cancel, and all you can have is 5. So 10 times 5/10 is 5. 10 times 5/10 would be 50/10. That's 5. So that's a great shortcut to multiply everything by 10 here. So 10 times 2a is 20a. All right, and then this one, 5 goes into 10. So 5 goes into 10 2 times. So 2 times that 3 up there, that's going to be 6. Another way to think about that, and this is a great way when you can do the math in your head just a little bit, is to take 10 and say 3/5 times 10 is like saying 3/5 of 10. And what's 3/5 of 10? Well, if I have 10, 1, 2, 3, 4, 5, okay, and 1/5 of 10, so this is old school like arrays, that's what my Aussie's doing right now. Each one of these is a 1/5 of 10. So 1/5 of 10, 1/5 of 10 equals 2, right? So if that's 1/5 of 10, what's 3/5 of 10? Well, that's 6. Okay, so now, even though I've made my circumstances actually look a little bit harder because it's like, wait, 10a, 20a, 5 and 6, these numbers don't work. It's still a little easier because now I don't have fractions to deal with. So now I'm going to look for the smaller value of my variable, which again, or not again, but in this case, so it's going to be 10a is smaller than 20a, and I'm going to subtract it from each side. I'm going to take it off. Take that 10a off. So that leaves me a minus 5 or a negative 5 equals 10a minus 6. And so now I'm adding 6 to each side. Now this looks weird, but it doesn't mean I'm wrong. It just means that I have to keep going with the steps I've learned. Even if it looks weird, doesn't mean it's wrong. So 1 divided by 10, I ran out of space again, could you tell, is 1/10. So 1/10 equals a. Okay, let me group all this stuff together again. Is it already grouped together? Oh, good. Okay. All right. So that's a start. What do we got over here? More fractions, a little bit more fractions, a little bit more decimals. I can always go back over these later if you want me to, but I don't want to make this too long. All right, find the dimensions of each rectangle, the perimeter is given. Okay, so this is just a question of writing an equation. And what's cool about these equations is you'll have all your variables on one side. It won't be those variables on both sides ones. So remember what the perimeter of a rectangle is. It's all the sides added together. So if I'm looking at this particular one, I'm going to say, all right, well, I got W and W plus 35, another W plus 35, and another W over there. Okay? So I add all those together. That's W plus W plus W plus W. So that's 4W. Plus 35 plus, oops, I forgot the 3. 35. 35 and 35 is 70. So 4W plus 70 is equal to the perimeter, which is 122. And then we just have to solve it. So this is an easier equation to solve. So that's subtract 70 from each side. So I'm going to get 4W. And see, this is one way that I've solved equations to say, all right, well, if this is a plus 70 on this side, it's going to be a minus 70 on the other side. Okay, kind of like a horizontal method. All right, so 4W equals 52. All right, and they say, well, if this is a times 4 on this side, it'll be a divide by 4 on the other side. And then you actually do the division, and that's 13. And then the dimensions of the rectangle are both the length and the width. So the width is 13, and then 13 and 35, 48, 48. So there's my 13 and 48. So there's the length and width. So very similar for number 14. Let's look at these word problems down here. Write an equation to model each situation, then solve, check your answer. Hans, it's always ethnic names they pick. They always pick something that isn't like the old storybooks that like our grandparents read, or I guess your great-grandparents, my grandparents. Dick and Jane, see Dick run, see Jane run. You know, they always have to have names that are different, which I guess I like it. I don't know. I like to put my favorite characters from TV in my word problems when I write word problems for stuff that we do at school. Anyway, I digress. Okay, so Hans, he's moving. He needs to rent a moving truck. Suppose Company A charges a rate of $40 a day. Company B charges $60 fee and $20 a day. For what number of days is the cost the same? Oh, finally, like an actual problem where someone might actually have to do this in their actual real life. You know, it would be nice for poor Hans to know which one is the better deal. Okay, so Company A, and we want to know when that's going to equal Company B. So Company A, $40 per day, and D is number of days. And it's a good idea to write something like that down on your paper, just in case you forget what you made the variable equal in the beginning. The other company is $60 fee, so that's $60 once plus $20 per day. And so that's a pretty easy equation to solve. We're going to subtract 20 from each side, making it 20D equals 60. Divide both sides by 20, 3 days. So 3 days is the answer. All right, so this is very similar to the last one, and I think what I'm going to do is leave it at that. If you want me to do the rest of them, I'd be glad to. Just let me know. I guess I'll see you next time.